All right, so this is going to be a video kind of reviewing the homework problems we have had during this week on similar figures. Just make sure my mic is on. Yeah, okay. Just making sure my sound's working. So, um, first off was identifying whether solids are similar and identifying the scale factor that went with them. So remember, solids are similar if the fractions of each individual piece matches up with each other, or each individual corresponding set of pieces matches up with each other. So for instance, we have 5 units for this line right here. We have 11.6 units for this line right here. These two green pieces are what we would call corresponding pieces because they both measure sort of the same thing about their respective shapes. This is the bottom line going from left to right of this rectangle. This is the bottom line of going left to right from this other rectangle that's in kind of the same position. So my first fraction here would be 5 over 11.6. And then again, it says it wants the scale factor of A to B, so that's why I put A on top and B on bottom. So 5 is shape A, 11.6 is shape B. Just in case they do end up being similar, I already have my scale factor kind of pre-written. So 11 goes this way, kind of like front to back, and 22.52 also goes front to back. So it'd be 11 over 25.52. And then lastly, we have, let me get my other color here. We have 4.64 and 2. So 2 goes top to bottom. 4.64 also goes top to bottom. So I have 2 over 4.64. Now, if they're similar, they should all end up giving me the same decimal essentially when I divide them. So for instance, if we go here, come on. Ah. If I go 5 divided by 11.6, I get that. 11.25.52, same thing, which is good so far. 2 divided by 4.64, and same thing. So they all come out to be 0.431 essentially, 0.431. So they are indeed similar. So similar, check. They are indeed similar, but it says write the scale factor of solid A to solid B. So I could pick any one of these fractions and say it's a scale factor. Like usually I pick the smallest one, which would be this one right here, and say my scale factor is 2 out of 4.64. Now this is usually not a good way of writing your scale factor because usually you don't want a decimal inside your fraction. So in order to write this correctly, I would either figure it out myself or I could type it in the calculator. 2 divided by 4.64, get your decimal, and then do math fraction, and it will tell you what the fraction is. So 25 out of 58. So 25 over 58 would be the scale factor, or sometimes they might want you to write it as 25 to 58 with the colon there. Both of these are just different ways of writing the same scale factor. Now this is for their linear measurements. This is for lengths, feet, perimeters, stuff like that. If they want the scale factor for the area or surface area, you would square both these numbers. So if I took that, where is it? If I took this and I squared that fraction, and then do back to math fraction, then this would be my scale factor. So this right here is a scale factor for the surface areas. And if I wanted volume, I would do 25 over 58, and I would cube it, and then put that as a fraction. Which doesn't count to be nice because it can't do numbers that small. So I would do 25 cubed, so that'd be the top number, and 58 cubed, that'd be the bottom number. So sometimes when the numbers are too out of whack, the calculator doesn't really do it that well. That's why I gave me the decimal back. But in that case, you just do it by hand. So just cube the top and the bottom. But again, make sure you're putting down the right scale factor for the right units. If it's just linear units, then it's just the scale factor you get when you make a fraction out of the numbers you get. If they want a surface area, you would square this. If they want a volume, you would cube this before you write down your fraction. Because again, they're in different types of units. What about the cylinders here? And again, always make sure you go from A to B if they ask you to. So make sure that you have the order right when you have your fraction initially. So in this case, 3 and 3.9 are both radii. So 3 and 3.9. And then 9 and 10.8 are both heights. They go from top to bottom of each cylinder. So 9 and 10.8. So if we divide these out here, 3 divided by 3.9 gives me that, and 9 divided by 10.8 gives me that. So they are not similar because the fractions did not come out to have the same decimal. So this would be not similar, not sim, we'll say, for not similar. So again, the fractions here don't work. They come out to be different decimals, not similar. And then obviously they don't have a scale factor because they're not similar. So you just skip the next part. So again, all three fractions or two fractions or however many fractions you can make, all your segments have to agree on what your scale factor is or what your decimal is if you want to say that they're similar. So assuming that you can get your scale factor, it might ask you to find certain things about the shapes using that scale factor. So here we have two solids that we're going to assume that are similar because it says given the following solids are similar. So that'd be 6 over 21 would be my scale factor of A to B. And again, how do I get 6 over 21? Well, bottom line here is 6, bottom line here is 21, so 6 over 21 would be the corresponding pieces. I'm going to actually reduce this by dividing the top and bottom by 3. So divide by 3, divide by 3, and I get 2 out of 7. So that would be a much easier scale factor to use going forwards here because that will help, again, just make the calculations that much easier. So it says the height of prism A is 5 meters. Find the height of prism B. So the height of prism, let me write my scale factor first. So 2 out of 7. Now this is A to B. So this fraction here also has to be A to B. So the height of prism A is 5 meters, 5. Find the height of prism B. So find it means I don't know it, so it'd be x. So then we just cross multiply. And I'm going to do this over here. We get 5 times 7, which is 35, is equal to 2x. And divide by 2. And we get x is equal to 17, I think. 17.5 rather. Come on. 35 divided by 2. Yeah, 17.5. So it'd be 17.5 meters if we want to label it correctly. And that would be my answer. So again, if they want a height or a perimeter or a length, use your scale factor as your base fraction. Set up your other fraction over here. One of these spots is going to be an x, and then just cross multiply them. Now the next part says find the surface area of B, or sorry, if the surface area of B is 200, find the surface area of A. So I start this pretty much the same way, 2 out of 7. But because I'm dealing with surface area, I'm going to square this fraction first before I do my cross. And when I do my cross multiplication, I have to remember that this 200 square meters is for prism B. So that's going to go on bottom. Because again, my scale factor goes A to B. So this fraction also has to go A to B. So the B number has to go on bottom. The A number, which I don't know, would go on top. So this would be 4 over 49, because that's what 2 and 7 squared are respectively, out of 200. You cross multiply here. You get 49x is equal to 800. Divide by 49, and you get x is equal to 800 divided by 49. 16.33 essentially. 16.33, and this would be meters squared. And again, this makes sense that the surface area of shape A is smaller than the surface area of shape B because A is a smaller shape than B. So if you get a bigger answer here, that means you probably put your x in the wrong spot. So if you keep getting answers that you know are wrong because they're too big or too small, maybe flip your x in terms of its position, and that might help you out. And the last question here deals with volume. So as you can probably deduce, it's going to be the same way here, 2 out of 7. But because it's volume and deals with cubic units, we're going to cube this fraction before we do our cross. Now in this case, the volume of 38 goes with prism A. So 38 is going to go on top because that's where the A number goes. And then the B number is going to go on bottom. So 2 cubed is 8. And then 7 cubed is 7 times 7 times 7, 343. Is equal to 38 over x. You cross, you get 8x is equal to 38 times 343. We get 13,034. And then we divide by 8. So divide by 8, and we get 1629.25. So 1629.25 meters cubed is equal to x. And again, makes sense that shape B has a bigger volume than shape A because it's supposed to be the bigger shape because again, it has the bigger number here. So that makes sense, which means I probably did the right thing here, which I'm pretty sure I did too. So that's how you solve these basic. This is kind of like the core of the entire week here, by the way, too, is being able to set up it with the scale factor and then cross multiplying whether you need to square, cube, or not do any of those at the first. So lengths, heights, perimeters, you don't square or cube. Surface areas, you square. Volumes, you cube. Use the unit label to help you out here. Cubic label means you're probably going to cube the fraction. Square label means square it. And then no square or cube means no square or cube. And when you square or cube, you always do it to the scale factor fraction, not the fraction with the x, but the scale factor fraction in most cases. You never cube or square the non-scale factor fraction, essentially. And the last one here is just a review of the word problems. So a painter is doing a portrait of a king. I should say a painter is doing a portrait of a king. The king is 72 inches tall. In the picture, they're going to be 20 inches tall. If the king's crown is 3 inches high, how high should it be in the picture? Well, just like before, we need a scale factor to start with, except that they don't give us the scale factor, at least not in a picture. But they say that the king is 72 inches tall in actuality, and the picture he's only 20 inches tall. So that means my scale factor is going to be 72 to 20. This is the actual height of the king versus the picture height of the king. Now, if you notice here, this time the bigger number is on top, and it really doesn't matter whether it's on top or bottom as long as your fractions are consistent, which is why I kind of label it off to the side here. Actual king, picture king. So that means the actual crown is 3 inches high. The picture crown, we don't know, so it's going to be x inches high. Make sure I do my mic check here. Still going? Okay, good. So that means I'm going to have to cross multiply. Okay? Okay, again, I always worry about my mic cutting out, so I have to make sure to keep checking it. So 3 times 20 is 60, and 72 times x is 72x, divided by 72, and we get 60 divided by 72, which is 0.83 repeating. So 0.83 repeating inches high is going to be how high the crown is in the picture, assuming he wants to keep all the proportions straight so it looks nice. So if you notice here, all the problems throughout the entire week boil down to the same thing. Get your scale factor, use it as a base to set up all your proportions. And again, if you don't remember, this is called a proportion. This whole idea right here, where you have one fraction equal to another, this is a proportion. That's what it means to be a proportion, two fractions equal to each other. The first one's always your scale factor. The second one's always kind of the numbers that you're dealing with. And then you just cross multiply. And if you're doing an area, square the scale factor. Doing a volume, cube the scale factor before you do your cross. That's it for this video. Again, it was hopefully a pretty routine week because, like I said, most of the problems kind of connected with one another pretty strongly here, more so than the last few weeks. So hopefully this RPS and stuff will go well for you. As always, if you have any more questions, let me know. Otherwise, hope you enjoy the video. Have a good day, night, evening, afternoon, whatever the case may be for your current predicament.